Guys, does anyone know what is a Docker? So initially in the on-premises environment, so initially where we are deploying our servers or where we are deploying our application into that servers, physical servers, right? Initially we are deploying our application into the physical servers, right guys? So physical servers means, what is the physical server? A Power Edge, Dell Power Edge R710. For example, this is the Dell PowerEdge server. Right, guys? You guys are knows, right? Dell PowerEdge R710. For example, Dell PowerEdge R710. Yeah. So, for example, this is the server. So, this is the server. So, in our on-premises environment, initially, we are yeah. So initially we are installing OS on these servers, right? CentOS CentOS S7 on this server. So this entire server, we are installing the OS CentOS 7. So something like a big innovative thought comes, a big innovative thoughts comes and a big innovative thought comes and so which solution, guys? Which solution is came? Guys, tell me what is the solution? So physical to
And
sorry.
phys- physical to like cloud.
No. Cloud before we have a one big innovative thought is there. Something like a developer doesn't want this much big of servers. So then what we installed
OEMs, huh?
in our laptops, in
OEM.
our lap, yes. Virtualization,
uh,
virtualize.
Virtualization.
So virtualization. So virtualization means something like either VMware company provides a virtualization or Oracle, a virtual machine. Something like OVM. Oracle also provides a virtualization solution. So in these virtual solutions, we install a OVM or VMware. So OVM or VMware, right? So VMware and so the rest of they took the 2 GB of RAM something like and they released of the rest of the resources. So we install the a number of OSs, number of VMs. Something like I installed a CentOS 7, CentOS a 7 OS. Then I installed a Red Hat 7 OS. Then I installed a Windows OS. So based on that resources, so we can divide and we can install the number of VMs. So something like here I installed a Windows VM, Windows Server 2000, Windows Server 2000, for example, 2018. So installed as a VMs. So these all are the VMs. VMs is nothing but a virtual machines. So we install the VMware and so we install the OEMs. For example, here the resources are something like 128 or something like 256 GB, 256 GB of RAM, 20 CPU, 20 CPU, and something like 3 TB of r- hard disk. So this much big of RAM is fit for for example, a production server, prod server. So, so this is the fit for the fraud servers. But for development servers, development people are less than below 5 people are using only, right? So this much big of servers, no need this much of big servers. So a big innovative thought comes and they created a virtualization solution. So virtualization solution means we can divide the resources and we can utilize resources with a small amount of VMs, small amount of VM. So something like uh, this is also. So this is also a same resource. CentOS, CentOS 7 for CentOS 7, we took the something like a 4 GB of RAM, 4 GB of RAM, 2 CPU, and 2 CPU and something like a 20 GB hard disk is enough. How much? So 20 GB enough is hard disk. So center is 7, 4 GB of RAM, 2 CPU, 20 GB is enough for a small VM. So this is a development server. For development servers, we need this much amount of resources. We need this much amount of resources. So so for so this is also this is also something like a virtualization. So uses the cloud also uses on premises, cloud also uses the virtualization. Okay, so cloud also on premises also uses the virtualization, cloud also uses the virtualization. Initially cloud also uses the virtualization concept only. Cloud also uses the virtualization and the physical concept only. So after that, a big innovative thought comes under so a solution called as a what is the solution, guys? Solution, guys? Containerization. What is this? Containerization. What is this? Containerization solution. So what is a containerization? What is a containerization? So containerization solution comes into the picture. So this much of RAM, CPU, we don't need 20 GB of RAM, 20 CPU, 4 GB. But it created a images. So container images. This images contains a OS and as well as application. This image contains a OS and as well as image. Image also. Image is nothing but SNTI 7, whatever it may be. So OS and application, sorry. So OS and application. OS and code. Application means code. OS and code also created a 500 MB, 500 GB. You see, so the innovation starts from, so here is a big amount of servers. So it comes into the virtualization. So this is a physical. So physical, then a big innovative thoughts comes and it comes a virtualization, then virtualization to containerization, a big solution, a big innovative thought comes and so a containerization comes into the picture. So start. So physical is initially it is physical, then virtualization, then containerization. So then containerization. So nowadays the containerization concepts also, the service also created in all the cloud environments, all the cloud providers. For example, ECS. ECS is nothing but Elastic Container Services. What is that? Elastic Container Services. A service released as a service in the AWS, it call it as a ECS. And so the containerization orchestration purpose, they created a service solution called as a EKS. What is that, guys? EKS. EKS is nothing but a elastic elastic Kubernetes services. So elastic Kubernetes services. So what is the difference between ECS and EKS? What is the a difference between ECS and EKS. We'll tell you guys. So we'll tell you. Now you understand, right? So how containerization concept comes, how containers comes into the picture. I will give you brief intro about the containerization, but you got the point, right? So from physical to virtualization, a innovative thought comes and here reduces the cost, resources, everything. And from virtualization to containerization, a big innovative thought comes into the picture and that reduces the RAM, CPU, and everything. Just it 500 MB, it created the OS image and the code, your code, and keep it in the servers and keep it in the servers. Yeah. For example, so this is your physical server. So this is your physical server. In this physical server, something like you install the virtualization and you install the CentOS 7. For example, this is the CentOS 7. So this is the CentOS 7. CentOS 7. In our VM, we install the containers. We 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 run the containers in the VMs. We run the number of containers in the VMs. You see, so there is a much difference. There is a big difference from physical to virtualization. Here, physical servers, so they created a VMs, and VMs in the VMs we created the containers. In the VMs, we created the container. In the VMs, we created containers, or in the physical server also, they created the containers. So something like, for example, this is the physical server. So this is the, for example, so this is the physical server. In this physical server, you installed a CentOS 7. For example, you installed a CentOS 7 on this physical server. And you can run the number of containers on your machine also, on your physical server also. You can run the number of containers in the physical machine also, a physical server also. Based on that, based on the configuration, based on the resources, we can run the number of containers on a physical server or a virtual machine or a virtual machine. This name call it as a container. This name called as a container. This name will
Hari,
call it
please
as a
correct me.
yeah,
Please correct me. One physical
yeah.
server have multiple OEMs and multi OEMs have different OSs like that, right?
No, no, no. So this is the, for example, Anand.
Yeah, yeah.
So what is this?
Physical server.
So this is the physical server. So this is a physical server. You are a user, right?
Hmm.
You are a user. Yeah. So how you can interact with this physical server? So this is the physical hardware. So this is the hardware, right? Hardware knows only binary
Software
language.
needed.
User knows only this.
Software operating
Yeah.
system. Yeah.
We need a operating system. So we need a operating system. For example, if it is a CentOS or whatever it may be, it is a Linux flavor, Windows flavor, or a Unix flavor, whatever it may be,
Okay.
right? So
Hmm.
install, then only you can interact with the server.
Hmm.
Otherwise there is a virtualization solution. So VMware also they created a VMware also a bare metal software. So that is also having the image OS, something like
Hmm.
VMware ESXi something like 6.0. So this is
Hmm.
also a OS.
Ah,
So this is
okay.
also a OS, but this is a bare metal OS.
Hmm.
Bare metal OS. So once you install the operating system, you can interact. Once you install the VMware, so VMware is only for to install the to interact the server, and it released the resources, and you can create the number of OSs based on your resources. You understood?
Yes, yes.
So what is your
Then
question?
containerization. Then containerization. How user interact with that containerization? How created?
Yeah, yeah. You will get. You will get it. You will get.
Okay.
Okay. You will get it. Just how you can interact with containerization. So containerization is just a container. Okay. So these containers will 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 install on either physical machine or a virtual machine. Okay. So yeah, I will tell you. I will tell you. You will get a, yeah. You will get a more clarity. So a virtualization for virtualization is the concept. So containerization is the concept. Physical server is the concept. So who provides the physical servers? Dell PowerEdge provides the physical. So who provides the virtualization solution? Which
Oh,
companies
yeah,
are
VMware. Yeah.
VMware company or OVM Oracle Oracle company or VMware company? They created the virtualization software, right?
Ah,
The
right.
same way, so containerization is the concept of the concept. So who provide the containers? Who provides the containers? A Docker. Docker is the
Mm.
company. Docker provides the containerization solution.
Okay, now got it. Okay.
Okay. So
Oh,
Docker provides the containerization solution. So containerization solution. We have a number of companies are there. Same like a VMware, Oracle Virtual Machine. But Docker provides a containerization solution. So introduction to Dockers and containers. Introduction to Dockers and containers. Continuous deployment, containerization with Dockers. Continuous deployment. So where we can deploy our application, we can deploy our application on either physical server or a virtual server or a container, right? Or a container. Continuous deployment, containerization with Docker. So what is a virtualization? So what is a containerization? Advantages of containerization over virtualization. So what is a Docker? Benefits of Docker, Docker architecture, Docker use cases, virtualization versus containerization. So Docker Compose. What is a Docker Hub? What is a Docker image? What is a Docker file? So these are the key concept in the Docker. These are the key concept in the Docker or a containerization. Okay. So what is a virtualization? You guys are knows what is a virtualization, right? So in computing, virtualization refers to the act of making a virtual version of the one thing together with the actual hardware platform, storage devices, and electronic network resources. For example, this is the a physical server. In the physical server, we install a hypervisor. Hypervisor is nothing but a VMware or Oracle virtual machine. Then you create the VMs, right? This is the virtualization. So what is the containerization? So containerization may be a system of internal freight transport victimization intermodal containers. The containers have standardized dimensions. So guys, you don't remember this. I will tell you the example. So containers. So containers, so something like this is the infrastructure, host operating system. In that host operating system, for example, this is the infrastructure. This is the host operating system. Host operating system is nothing but a CentOS. For example, here this is the CentOS. CentOS is installed. So in the CentOS, we run the container daemon, container service. Once we install the container service, so we can run the number of application. We can run the number of containers. Can run the number of containers. So advantages of a containerization over virtualization. So what is the advantage? Increased the portability. Portability means a small. So and improved scalability, it will be scalable easily. Simple and fast deployment and enhanced productivity and improved security. So if you go with so something like what is the advantage of the containerization? It is increased portability, scalability, simple fast deployment, and enhanced productivity and improved security. So what is a Docker? Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. Guys, what is a Docker? Docker is a tool. Docker is a tool designed to make it easier to create, deploy, run applications by using the container. Containers allow a developer to package up an application with all the parts of it needs, such as libraries and other dependencies, and deploy it as an one package. By doing so, thanks to the container, the developer can rest assured that the application will run on other Linux missions, any other Linux missions, regardless of the customized setting that mission might have that could differ from the mission used for writing and testing the code. For example, a developer created the image with the code, so that container will run it on any flavor of the Linux. It will it will run it on any flavor of the Linux. For example, you created an image, you can run it on Windows, you can run it on CentOS, you can run it on Oracle Linux, you can run it on CentOS. So we can run it on AAX, you can run it on UX, you can run it on Sun Solaris, any flavor of the Linux, the Docker will run, the Docker image, the container will run. The container will run. Docker from whom? So, who created this Docker? Docker is the tool that is designed to benefit both the developers and system administrator, making it a part of many DevOps, making it a part of many DevOps developers and operations tool chains. For developers, it means that they can focus on writing the code without worrying about the system that will ultimately be running on. It also allows them to get a head start by using one of the thousands of programs already designed to run in a Docker container. As part of their application, as part of their applications, as part of the so ultimate running and as part of so them to get a head start by using the one of thousands of programs already designed to run in a Docker container as part of the Docker application. For operation staff, Docker gives flexibility and potentially reduces the number of systems needed because of its a small footprint and lower overhead. It's a small footprint and overload head. So we can run the containers on something like a one physical server or one VM. So we don't need a number of VMs. We don't need a number of servers. We don't need a number of servers. For example, operation staff. Operation staffs means Linux engineers, Windows engineers, whatever the engineer. Docker gives a flexibility and potentially reduces the number of systems reduces the number of systems reduces the number of system it can run on only one server. Docker gives flexibility and potentially reduces the number of systems needed because of its a small footprint and overhead lower overhead. So what is a Docker? Docker may be a set of platform as a service product that uses OS level virtualization to deliver software package in a package known as a container. Container are isolated from each other and bundle their own software package, libraries, and configuration files. So isolated. Containers are isolated from each other and bundle their own software means code and libraries and configuration files. They will communicate with one another through well-defined channels. For example, this is the Dell PowerEdge R710 infrastructure. This is the host operating system. What is the host operating system? For example, you install a CentOS 7 or a Red Hat. In the CentOS 7 Red Hat, so we install the Docker service and we can run the number of container applications. For example, this is a Node.js, this is a database, Oracle, this is a MongoDB, something like you can run number of containers on a one operating system. So Wiki says Docker is a container management service. Docker is a container management service. The keywords of Docker are develop, ship, and run anywhere. The keywords of a Docker are develop, ship, and run anywhere. The whole idea of the Docker is for developers to easily develop the applications, ship them into the containers, which can then be deployed anywhere. Which can be deployed anywhere. Benefits of Docker. Benefits of so so return on investment and price savings. It will be a return on investments and price savings. The standardization and productivity, CI potentially, compatibility and maintainability, simplicity and quicker configurations, rapid preparation, continuous preparation and testing, multi-cloud platforms. So we can create a one container and we can run on Azure platform, Azure cloud, or AWS cloud, or Oracle cloud, or any cloud platform. So Docker architecture. So Docker architecture. For example, so this is the client. For example, you are the client. So you create a. So what you are doing in the Docker, we have a commands: Docker build command, Docker pull command, Docker run command. Docker build. So Docker build means you can create the image with your code. That is the Docker build is nothing but a container build. So Docker pull is nothing but we can pull from the Docker host. So then we can run the Docker. It will run the Docker. So this is the daemon. Definitely, if you want to run a container on a mission on a container, definitely we need to run the Docker daemon. The Docker host is nothing but a server. In the server, so we run the Docker containers images. What are there? In our Docker in our physical server or a virtualization server, there is a two components: containers and images. Image is nothing but a CentOS 7, whatever it may be. The images, whatever the build is, right? These are the images. So where it will be stored in the under the images, we can store it in the under registry. Registry is nothing but a repository. This repository is nothing but a Docker Hub repository. So Docker Hub repository, if it is a AWS repository is there. Azure, their own have depositories are there. So this is for the Docker Hub repository. We can store it here and we can build, we can store it and we can run it on a server. Run it on a server. Docker use cases. Simplifying configuration, a developer productivity, server consolidation, a multi-tenancy, code pipeline management, and app isolation, debugging compatibilities, and rapid deployment. So these are the 8 Docker use cases. So virtualization versus containerization. So virtualization versus containerization. So virtualization is nothing but a so in the lower level, there's something like this is the Dell coverage infrastructure. Unless you installed a which operating system, something like there is a operating system is called as a Oracle virtual machine or something like a VMware virtual machine. So once we install the virtual machine, so then we install the VMs. This is the VM, this is the VM, this is the. In this VM, again we install the binary files, library files, and application. Binary files, application, and library files. Binary files, application, and application. So this is the virtual machine environment. So the container environment is nothing but a infrastructure, Dell PowerEdge, host operating system, CentOS 7. We run the Docker daemon. Then we can install we can run the container. So we can run the container. So there is no need of if you have a guest OS is nothing but a VMs. So VMs. Understood? So Docker. So Docker file. What are the Docker files? Something like we can create a Docker file, and or the Docker file is nothing but we can push from the Docker hub and we can create a image and we can deploy it on the server. Okay. So what is a Docker image? What is a Docker image? So something like a, so we can write the Docker file. A Docker image is a file comprised of a multiple layers that atmosphere execute code in the Docker instrumentation. An image is basically engineered from a directions for a whole and workable version of the application that depends on the host of a kernels. So what is a Docker image is nothing but a, so Docker image is nothing but a, so something like so you want a Docker image. So image is nothing but a your code and CentOS. So your code and CentOS, something like a how we can create the images. We can create the images, for example. Yeah. So a Docker image is nothing but a Docker image is nothing but this is the Docker file. So this is the Docker image and this is the container. So a Docker, something like so a file is there, Docker file. Let me give you a file. So this is the Docker file. So this is the Docker file. So what it contains, this Docker file contains. So it will take the, so for example, this is the repository. So where all the images will be stored in this repository. Something like is this in this repository having a CentOS 7, CentOS 7 image. For example, CentOS 7 image. So once you took that from CentOS 7, it will get from the CentOS 7 copy dot app. This is the something like this is our code, and we can run this code as a something like so with your image and code. Your image is nothing but a OS plus your application. Application is nothing but a code in our layman language. So so if you run this Docker file, it will create the Docker image. So which Docker image you can create? So it will create the a CentOS 7 Docker image with CentOS 7 a Docker image, CentOS 7 image with your code. Combine and create a Docker image. So this is the a Docker image. So we can create how we can create the Docker, something like a Docker build command. So through Docker build command, so we can create the Docker images. So in the container, so we can run the this image as a Docker container. You run the image as a Docker container. So then here you deployed application called as something like a WhatsApp.jar. In this container, what is a CentOS 7 image with the so WhatsApp jar, WhatsApp.jar. Something like in our if you if you if you if you get it from in the internet, something like a WhatsApp.com. So where it will get it from? It will get it from the container. It will get it from the container. So so once you build the image, again you can push it to the again you can push it to the Docker Hub repository. What is this? You can push. This is the repository. So the repository. So this is the a Docker Hub repository or a artifactory. What is that, guys? Artifact. You guys are also heard about the artifactory, guys. Artifactory. Hmm. So artifactory. So what is the artifactory? JFrog Artifactory. So what is the JFrog Artifactory? So JFrog Artifactory is the single solution for housing and managing all the artifacts, binaries, packages, files, and containers and components. So what is this? A JFrog is the Artifactory tool. JFrog, Nexus. So this is the in JFrog Artifactory. So no type. These all are the Nexus repository. Manage components and binaries will do artifacts across the software supply chain. Something like a containers. Containers will be saved under the Artifactory. So this is the Artifactory. This is the Artifactory. So which Artifactory? Docker Hub repository, Docker Hub Artifactory. So the images, container images will be stored under the repository. Container images will store it under the Artifactory. Artifactory container images will store it under the Artifactory. Something like this is one of the container. This is one container. So I will show you guys. Dockerhub.com. Dockerhub.com. Yeah, it is kind of like yeah. So this is the a Docker Hub repository. This is the Docker Hub repository. So I'm searching for the CentOS 7 image. I'm searching for the CentOS 7 image. Yeah, you guys. So this is the CentOS 7 image. Will show right the size of the will show. Once you fill into your in our OS, in our CentOS 7, it will show guys. It will show the size of the here also it will show the size, but so the application UI change I think before it is showing 500 MB. Yeah, we'll show you tomorrow. So once we download it from, yeah, this is the Docker Hub repository. So this is the Docker Hub repository. In this Docker Hub repository, we have a Docker images. We have a Docker images. So you can get the CentOS image, and you can write the we can write the code, right? Once you write the code, you can combine with our image or our code with combine it, create a image, and we can deploy it on the container. We can deploy it on the container. Guys, understood? Mm, yeah. So this is the a Docker file. So once you build the Docker build, then you can, it run. This is the image. So it will create the image. Once you run that image, it runs the container. Runs the content. Runs the content. So what is a Docker Hub? Docker Hub is a service provided by the manual labor for finding and sharing the instrumentality pictures along with your team. It provides the subsequent major features. A repository is push and pull instrument instrumentality pictures built mission mechanically built instrumentally. So this is not a good way, guys. So what it contains the images. It contains the images. Docker Hub contains the get images from the Docker Hub and upload images from the Docker Hub. You can get from the Docker Hub, and you can get from the upload from and get from. Okay. So what is a Docker Compose? So Docker Compose is something like we can compose. Compose is the tool for outlining and running a multi-container Docker applications with Compose. So you employ a YAML file to put together your application services, outline the services that structure your app in Docker Compose. That YAML in order to that they are running along with the associated isolated settings. I will show you guys, no worries. So Docker images and containers. So these are the Docker images. So Docker images are the read-only templates used to create a containers. So these are the just read-only templates used to create the containers. So built by Docker users. Who built by Docker users? Stored in Docker Hub or your local repository. So Docker containers, isolated application platform contains everything needed to run the application built from one or more images. One or more images. So Docker registry. So Docker registry is nothing but a Docker hub. Docker registry is the storage component for your Docker images. Docker images. This is the a registry. Docker hub is the registry. So Docker is the registry to storage component of a Docker images. Docker images, we can store the images in either public or private repositories. We have a same like as a Git private and public repositories are there. It's in the same way we can Docker Hub also we can store the images in the either public or private. So private means no one can use that images. So public means everyone can use that images. So Docker Hub is the Docker's very own cloud repository. So why uses Docker repositories? Control where your images are being stored, integrate image storage with your in-house deployment workflow. In-house deployment workflow. So Docker architecture. So this is the client, Docker host, and registry. So whatever you build so something like with your Docker file, you can build the Docker, and we can run it on the host on the server, or we can push it to the Docker repository. So Docker pull is the command. So we can pull from here and then push it to the repository. Docker run is nothing but from image to you can run the containers. You can run the containers. Build, pull, run. Guys. So this is the Docker architecture. Docker architecture. Guys understood? Guys are understood? So
What
this
is
is
the
the
use of
repository.
what is the use of Docker containerization? Means exact use in a user perspective.
Exactly. Yeah, something like. So what is the exactly use? Nothing but so the innovation thought it reduces the infra. One example is reduces the infra and it is a portable and we can run. So something like for example in WhatsApp. In WhatsApp, so how many modules are there? Anand. For example, we have a modules called chat,
Call, video call, chat, status.
status, and contact,
Mm.
right? So
Mm.
three applications, these are the three containers.
Mhm.
Okay. So this is our VM, or for example, this is a physical server. This is a virtualization server. So entire application code will be run it on one VM, right?
Yeah.
Entire everything, three modules. So this is a VM. So this is a physical server. Okay, this is a physical server. If something goes on the, if something goes on the here, we have a three modules. For example,
Mhm.
so if something goes on the contacts, but every application will be crashed. Everything, all these three also, apart from two, these two also affecting, right?
Mm.
It will affect on entire application.
Mm.
Okay.
Okay.
So container uses is nothing but a, so we can run the a microservice. This chart call it as a microservice. What is this? This is one of the microservice. This is one of the microservice, and this is one of the microservice. Okay. So micro a service. So microservice. If something goes wrong on this container, if something goes on this container, so it will affect on other containers. No, it will not affect on other containers. So the status and contacts will work. Only the issue with the chat. Only the issue with the chat. So developers comes and verify the code in the chat only. Verify the code in the chat only. For example, if you see something in the ELK, something like ELK is nothing but a elastic ELK logs, where we can see the logs in the developers. Developers will see the logs in the, so something that related to charts. That code is related to chart. The issue with related to chart. So once again, you develop the code and create a container and run it. So this will not impact. So this is a nothing but a microservices or a container. If something goes wrong on the VM, the entire application will crash. So the entire application will, the production will goes down. So here also the production will goes down. So we can segregate the microservices, and we can deploy every module in the microservice. Every module as a microservice. It will not affect on the other services, other modules, and it will run it on a, if so something like so we need something like a Red Hat. So Red Hat is the enterprise Linux. So Red Hat is the enterprise Linux, or something like we need to buy the a license for the Red Hat. So we can purchase one Red Hat server, Red Hat license, and we can run it on a number of containers. We can run it on number of containers. So we don't need to buy, or we don't need to purchase the license on the containers. We just purchase license for the OS. So it easily to manage, it easily to, so the cost perspective, so the microservice, something like the deployment perspective. So it is very easy to manage. It is a very easy to manage. Now you understood? Something like I don't need this much amount of resources, this much amount of resources. I will give you a good example for you, Anand. For example, this is a VM or a physical server, right? So this
Mm.
physical server having a RAM, for example, 16 GB RAM, okay?
Mhm.
CPU, something like 4 CPU. 20 GB hard disk. Okay. So only 20. For example, this is a VM, right? So we need 16 GB of RAM, so 4 CPU and 20 GB hard disk. So you installed a CentOS 7. CentOS 7 OS. For example, this is my physical development environment. This is my QA environment, and this is my pre-prod environment. This is my dev environment. So this is my QA environment. So this is my pre-prod environment. Pre-prod. So we have a three environments here. So we have a three environments here. But for this resources, so we will run the at a time we will run the 4 containers based on the resources. Okay. So we'll run the 4 containers at a time. So we can run the how many containers at a time? 4 containers. My Dove environment having 4 containers. My QA environment having 4 containers. My pre-prod environment contains 4 containers. 4 containers. For example, so without development environment, without develop the programs, QA will not test, right? Anand. After the deployment, after the developers develop the code, then they will apply it on the dev environment. So meanwhile, I will stop these 8 containers. I will stop these 8 containers. I will stop
Why?
8 containers. No need of write. So once we develop the application, we test it in the development environment, then we will deploy it in the QA environment. Otherwise, QA will not work, right?
Correct.
Got it, right? So I will
Yes.
stop 8 containers. Those are QA and pre-prod.
Part.
Pre-prod environment.
Mm.
So I stopped all these containers. Okay.
Mm.
I just up these 4 containers. So once we develop that code and we deploy it into these these 4 containers. Okay.
Mhm.
So these 4 containers. Yeah. So it's working fine. Then I will stop the
Dev containers, huh?
8 containers.
Okay. Mhm.
8 containers. Those are dev and pre-prod. Okay. So this time I only up the QA servers.
Mm. Okay.
Once we deploy the code in the QA environment, QA people will test it. So
Mhm.
once it is tested, so this good, then we will deploy it on the pre-prod. I will stop 8 containers. Those are
Dev and QA, no?
tell me dev and
QA.
QA environment. So this time prod is up. So then QA people verify the prod environment. If it is looks good, then they will stop the pre-prod. Then they will up the dev environment. So within the one server, we can run your entire infra. We can run your entire infra. The cost reduction, the portability, the maintenance. So everything will be easy. Now you understood?
Mhm. Yes, yes.
Now you
The same
understood? Guys,
concept
understood,
we'll
right?
do it. Yeah, yeah. The same concept we'll do in cloud also, right?
Yeah, that's why I already told you, right?
Ah.
So before, so initially, the cloud also supports the same like as a on-premises environment,
Mm-hmm.
right? The cloud also, there is no services for the something like. So just they created a service called as a, what is the service, guys? EC2 service.
ECS or
Okay,
E
EC2
Kubernetes, right?
instant. Before there is no
Okay.
ECS and
Ah,
EKS. So
okay.
after innovation of a containerization, they created
Mm-hmm.
as a service. So service before it is EC2 only. There is no ECS, container service. After containerization, they also create after after containerization. So they created a service called as a created a service called as
ECS.
ECS, Elastic Container
Containerized service.
Service. So Elastic Container Service. After innovation, after innovation, so they created a service called EKS. What is it? EKS. EKS
EKS.
is nothing but
Elastic Kubernetes Services.
Elastic Kubernetes Service. Elastic Kubernetes Service. Now you understood? So before only one service, that is a EC2 instance, compute EC2 compute service. After that, after containerization comes into the picture, so every cloud environment, for example, Oracle, Oracle service called as a OCS or OKS, Oracle Kubernetes Service. Azure, Azure also created AKS, GCP, GKS, or something like a Kubernetes. So who invented Kubernetes? Google invented the Kubernetes. Okay,
Mhm.
AWS, it is called as a
EKS. Huh?
EKS. Understood? So now why container comes? Container will manage it under one instance or something like it is a portability. So we can, so something like here in one EC2 instance, something like in one VM, one EC2 instance. So we can run the number of containers, right? So here also we can run the number of containers. But they have created a separate service as ECS and EKS. Right, got it? So tomorrow we'll show you how to install a Docker on a CentOS machine and how to how to pull the Docker images, how to push the Docker images, how to deploy a Docker image into the how to deploy our application to the Docker as a container. We'll show it on the tomorrow class. Okay,
So the Docker
got you
pull,
guys.
Docker, all these things are to create a container, right?
Yeah, to create a container.
That concepts. Okay. Tomorrow you will
Yes,
practically show it, right?
I
So
will show you.
then
I will
we
show you
can.
how to install. So in OS in CentOS 7, after CentOS 7, just we install the Docker
Mhm,
daemon.
mhm,
We install the in the CentOS 7. So we install the
mhm,
Docker daemon. The same like as the package management, right? How you can install the other packages, HTTPD. The same like we can
mhm,
install the Docker.
mhm,
Docker daemon. Daemon is nothing but a service, right? You already installed the HTTPD service, right? The same like
mhm.
yum install HTTPD. The same way you can install yum install Docker. It is an inbuilt package. Okay. So I'm install Docker. Once you install the Docker image, you can start the systemctl. Systemctl start Docker. Once you start, it runs the Docker daemon. You can run the number of contents in the Docker daemon. So when you can run the Docker containers. So if the Docker service is started, if the Docker service is running, so then only we can run the containers. Otherwise, we cannot run the container. Okay, guys, understood?
Yes, yes.
Victoria, home, Patrick, Jason, home. You guys are understood?
Yes.
Yeah.
Yes.
So you will understand. Yeah, guys. You will understand more on tomorrow. So we'll show you the practical, right? Tomorrow. You will get it, guys.
Uh,
You will get it
Hari, one
more
request,
understand.
Hari. Hari, the same whatever you today showing in figure means in drawing, na?